We're going to talk about some different kinds of factoring here. I'm going to do a very brief review of what you may have learned in your Algebra 2 and Algebra 1 days, the box and diamond method for factoring quadratics. And if you have some other method, that's fine. The key is you have to be able to consistently and quickly be able to factor quadratics. So in the box and diamond method, remember we multiply these and say the product is going to be 12x squared, and we say that the sum is going to be this 7x, and then we look for what two things multiply to be 12x squared and add to be 7x, and hopefully you can see that that's going to be a 3x and a 4x. And then you go to some version of your box and you can put the first and third terms in one of the corner boxes, and then what we do is plug these other 3x and 4x's into the remaining boxes, and then we are looking for example, in this row, what do they have in common, and that's going to be an x. And what in this column do they have in common, and that's going to be a 4x. And so now you know that the 4x times the x does indeed give you the x squared, and you say x times what will be the 3x, and so that's going to make that be a plus 3. And similarly, 4x times what will be 4x, so that's going to be a 1. And as a check, you can say that the 1 times 3 equals 3. So our factorization becomes the terms that are on top times the terms that are on the bottom. So at any rate, however you do it, we have to be good at that. So let's do a different kind. So this we're going to call factor by grouping. So a little different strategy, because we'll get not just the 3 terms, but we'll get something like, usually 4 terms, so 3x to the third minus 2x squared plus, I can't keep my pen in the game here, plus 12x minus 8. So the idea here, when you have 4 terms, is our box and diamond strategy is not going to work. But if we pair these up and then look for the greatest common factor out of each pair, so in the first 2 we can pull out an x squared, and that will leave behind a 3x minus 2. Now if this is going to work, we need for the second parentheses to leave behind a 3x minus 2. And so you can see that if you factor out a positive 4, that will indeed leave behind a 3x minus 2. So then we can factor out the 3x minus 2, and so that comes out as a 3x minus 2, and leaves behind then the x squared and the plus 4. And so if x squared plus 4 could factor more, we would do so, but since it doesn't, that's the end of our story, and that will be our factorization. So another type of problem is going to be where we look for the greatest common factor first. And in fact, we're always looking, no matter what kind of problem it is, we always want to have our eye out to get the greatest common factor first. So if we have something like, say, 18x to the second plus 6x, then if you see that there is a 6 that goes into both 18 and 6, and that x squared and x both have an x in common, we can pull out that 6x, and that will leave behind a 3x plus 1. And sometimes this will factor further, but in this case, that's the end of the story, and so that will be it. We can sometimes be asked to solve equations, so this will take our idea of factoring and go another step with it. So if we have something like, say, 2x to the third minus 2x squared equal to 18x minus 18, then if we're going to try to solve that, first we want to get everything on one side of the equal sign so that it's equal to 0. So we're going to bring these terms on the right over to the left. So leaving the 2x cubed and the minus 2x squared where they were, subtracting the 18x and adding the 18 will make that equal to 0. So for factoring to be meaningful, we need for it to be equal to 0. Now we can do our strategy. Since we have 4 terms, like we did before, we're going to pair these up and look for a greatest common factor. So, and that I think was, so here we can factor out, I believe, a 2, did I write that problem down? I did. So factor out a 2x squared, and that will leave behind an x and a minus 1. And in the second pair, if we pull out that 18, then that will make this be a positive x, and then if we factor a negative out of the 18, that'll make that be a negative 1. This is good news because we have these x minus 1s are the same, so that's going to make us able to factor that out. That will leave behind a 2x squared and a minus 18 equal to 0. Now we can factor this further. So if we first factor out that greatest common factor of 2, that will leave us with an x squared minus 9. And you can either do your box and diamond, or if you recognize that as the difference of 2 squares, I'm going to bring the 2 all the way out in front. The x minus 1 will be there, and the x squared minus 9 will factor into x minus 3x plus 3 equal to 0. Now we have these things that multiply to be 0, so any one of these could be equal to 0 and give us a solution. The 2 is never going to be 0. There's no x in there that will make that 0. The x minus 1 could be 0, the x minus 3 be 0, and the x plus 3 be 0. And so that's going to leave us with 1, 3, and negative 3 all as solutions. I'm going to go to a new panel and do one more here. So the last thing we have to be able to do is the quadratic formula in case this doesn't factor, in case we get a quadratic that does not factor. So if you remember, which you must, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So if we have a question like, say, x squared plus 4x equals 4, before we can use the quadratic formula, just like with factoring, we have to first make it equal to 0. So we can subtract that 4 to the other side. And if you try to factor this, nothing is going to work. So then we're stuck using the quadratic formula. So we get negative b, and the b is going to be the 4, so that's negative 4, plus or minus the square root of b squared is 16, minus 4a is the coefficient of x squared, which is 1, and c is the constant, which is a negative 4, and all over 2 times 1, which is 2. So cleaning up a little bit here, we can see the 2 negatives are going to make that be positive. 16 plus another 16 is 32. And we can break down the square root of 32. And you can do it in a couple steps, or if you recognize that 32 is 16 times 2, that speeds the process up. And that's going to become negative 4 plus or minus 4 square root of 2 all over 2. And then we can separate that fraction into negative 4 over 2 plus or minus 4 square root of 2 over 2. And now we can see that this will reduce to be a negative 2. That will reduce, and our final answer will be a negative 2 plus or minus 2 square root of 2. All right. I will also put some more practice problems, some worksheets with answers to them if you find that you need more practice on this graphing, particularly the box and diamond stuff. You can work some problems and check your answers. All right.